Hello. Let's get started. Why is this not? No. I'll make this bigger. Well, I guess I can't. All right, so hopefully this is being recorded. For today, Python Lab, before I go into the Python Lab, because I was doing a couple of things on Monday and Wednesday, instead of showing how to do some stuff, I will let you struggle with it and then I'll go around. But let me define what I want you to do for the Python Lab 2 before we jump onto the Python. What I was showing, and I uploaded some code on Wednesday and Monday, was these quadratic shape functions. So since I already implemented those, I want you to do the linear shape functions. So the idea is we have a mesh that I'm gonna define here. So copy this because after I do this, we're gonna go to the Python Lab, you won't see this. So we have a mesh in 1D, which consists of a bunch of nodes and a bunch of elements, right? So this is the x-axis. And let's say that for the mesh, what we need is the nodal coordinates. So you're gonna save an MP array. And that one you can choose the ones that you like, but let's do 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 4, 5. Let's say we have, that is the array of nodal coordinates. And the other thing that we need is the elements. So this is node. Actually, let me change things a little bit so it's not as obvious. Let me do 0, 5. Let's do it like this, so that you see. Otherwise, it's not as general. So here, this is node 0. This is node 1, the one with coordinate x equals 5. This is node 2, 3, 4, and 5. So this is x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, x equals 5. So the nodes are 0, 2, 3, 4, 5, 1. Their coordinates are 0, 5, 1, 2, 3, 4. And the elements, this is element 1, this is element 2, this is element 3, this is element 4, and this element. But also doesn't matter, we don't have to do it like that. Let's just do this is element. These are arbitrary. Someone was asking at some point whether I need to always name them in order. No, I don't have to. So just to show that these are arbitrary and they still work. So the element array, the first element is made out of nodes 0, 2. The second element is made out of nodes 2 and 3. Third element 3 and 4. Fourth element 5 and 1. That's the only thing that we do have to do is name from left to right. So for the element 4, the nodes are 5 and 1. That ordering does matter. And element 5 is 4, 5. All right, so that defines my mesh. And then the extra thing that we're gonna do, the mesh you have been already doing for the homework 1. But the extra thing that we're gonna do is we're gonna define these points. Actually, I already know what I want to do. Let me do. We're gonna define those points. which we're going to store in an array. This is the value of the function. These are the UIs. We're going to store in an array that we're going to call node U. It's another NP array. And these are the values of the function that I want you to interpolate. And let's just do 1, 2, 4. Here you need to be careful. You need to be careful. So this one, actually, let me name. So these have to have the same numbering as the node. So this one right here is the same as U0, but U1 should be this one. Then U2, then it has to have the same numbering as the nodes. So note the nodal values of U have to correspond to same order as node X. All right, so then the first node, I'm going to assign the value 1 for the function I want to interpolate. Then for the second node, so U1, that one, let me do, let's see if I have enough. 16, then the second one, I'm going to do 2. I'm going to run out of space. Let's do 2, 4, 8. How many should I need? So 1, then I missed one more. Let me do 32. So that I have nice powers of 2. All right. So you can see that even though it says 132, 2, 4, 8, 16, because I'm gonna put them at these coordinates, right? So I'm gonna put value 1 over coordinate 0. I'm gonna put value 32 over coordinate 5. That's what I mean that they have the same ordering. I'm gonna put value 2 over X equals 1 and so on. So that's one thing. And this is the way any FE package would do. And that's it. So what I want you to do is I want you to plot, let me put it in red, and you can work in pairs if you want. I want you to plot the function UHX that you get by doing the sum of NI UIE with a few hints. So one is that this interpolation is defined per element, which means that if you want to plot it over the entire domain, you need to loop over the elements and then plot for each element. The other is not a hint, but I want the linear shape functions, since I was doing work with the quadratic ones. So just use the linear shape functions. And I also want you to plot DUH dx, which again is gonna be the sum of dnix dx times the UIE values. That's basically what I want. I want you to plot the UH over the entire domain X from 0 to 5. And then the thing is you have to be careful because the interpolation sum of shape functions times nodal values is defined per element. So for plotting over the entire X from 0 to 5, you'll have to have a loop over elements. All right, questions before we get started? Otherwise, let's go. I think I'll give you a few minutes, 20 minutes, and then I'll do it. And then I'll go around. If you have questions, I can help. Yes, we have to do it inside of each element. So if you do it 0 to 5, the way I was doing it, so this works, so you need a single element. So in my example, Wednesday, the element was 1. So this was doing it they have to they have to do these are the single element. So in this case, you have to element 1, for example, you have to go from 0 to 1. But then for element 2, you have to go from 1 to 2 to the so what you need is a loop over the elements. So for each element, the beginning is the and then do from whatever that is next to whatever is next to and yeah, somewhere, I don't know if you can also call that. So you cannot just like that. Either the color or that you download the color Yes. Yes. So that looks correct, but technically like the fact that you are they define that together. And then okay, and then you have for loop of A, perfect. Right, and then what you need to do, that's perfect, that's perfect. So what you need to do is, if you don't need that, but you need, you have the element right. So what you need to do is add element I. Element I comma 0 will give you the first half value. Element I comma 1 will give you all. And then you can have the two nodes. All right. This is actually nodes 0, 1, then 1, 2, and so on. So that might not be correct. Yeah. But what you do need to, so you need to exactly. Yes. This is from my previous. Yeah, that one we haven't done that. That one is for an element that is always between -1 and 1. But here, these x1 and x2 are based on the element coordinates. So you need to pass them as well. It changes for every element. It changes. So if you look at the code from Wednesday, I pass x and I pass a set of parameters, right, which define the node coordinates. So x1, x2, and x3 are the coordinates that specify that element. So here, but you have the open, yeah, that one. We haven't gotten to that point yet. This this psi is another variable. But you know, the shape function is fine. It's just that the x1 and x2 is whatever the coordinates of that element are. So that one, you don't know. For that element, it's -1 and 1. But here you can see for the first element is 0 and 1, for the second element is 1 and 2. So it changes for every element for this example. So you need to pass that equation. You cannot just do one. Okay. So like for element 1, the 0 to 1, you know, for yes, but these are not you just need two shape functions, and every element will use the same shape functions. So every element has two, the one that goes down and the one that goes up. And what you need to pass is what are these two points. But you need to pass them as an argument. So you go to what I do. I'm passing them as in params. So params have the coordinates of the area. It's not a zero, it's whatever I pass. So you know, params have that. It's 0, 1, 2. So if my element has 0, 1, 2, then params has 0, 1, 2. But if I change this, I think that, you know, 4, 5, 6, then params will have 4, 5, 6. Okay. So you can see, I mean, when I evaluate in 1 and 2 and 3, I pass the x value where I want to evaluate. And then I also pass in params, I pass the coordinates of the nodes. Okay. So that I can use, I mean, the point is that I don't need to define any function for every element, because then I will have, you know, you have 5 elements, yeah, you will need 10 functions. If you were to define for every element its own function, then you have to do 10. That's cumbersome. Rather, just 1, 2 functions, but in this case, there are 3 functions, and that's it. And the only thing that we change is the x that I pass the value, but also the params, which has coordinates of the element. So for a given element that, like I said, has 0, 1, 2 coordinates, then I pass in params, I pass 0, 1, 2. Then there's another element here that has coordinates 4, 5, 6. Then I evaluate, I call the same function, but I just say, oh, but this element has 4, 5, 6 as the coordinates. But I always call the same function. That's why. Well,
Why do you define x1 and s2 as the same time both?
No, because every time I call the function, the function needs to know what the coordinates of the element are. This changes every time I call the function. It could change. Because again, imagine that I have these 5 elements and I want to call n1 function for this element, right? Then I need to pass the coordinates of that element and then the value of x that I want to evaluate. So this element is between, I don't know, 3 and 5, right? The x is between 3 and 5, and there's no other coordinates at 3, 4, 5, right? And I want to evaluate n1 for this element. Then I call the n1 function and I pass the value of x where I want to evaluate, say 3.5. But I also need to pass the coordinates of the element. I need to tell it, oh, this element has coordinates 3, 4, 5, and I want to evaluate n1 at x equals 3.5. But then imagine that I want to evaluate this other element that has coordinates 7, 8, 9. And I want to evaluate, I don't know, the second shape function. And I need to call the second shape function. And I need to say, I want to evaluate at 8.7. And this element is made out of nodes 7, 8, 9. So if I need to pass both information, I need to pass the information of where I want to evaluate the function. But I also need to tell it what these element coordinates are. Otherwise, the function will don't know. You cannot define it ahead of time because every time I call it, I need to tell which element I'm evaluating. Otherwise, there's no way to know. Otherwise, you're gonna go back to this idea of you will need, all 10 functions so you can call whichever function you need. So that's, you don't want to implement that function.
Right.
Better to just implement 2 and just pass the information. Right.
Thank you.
Yep. The idea being, you can see that the shape function of 1% value is even another. So it doesn't mean the two functions, and the function is the value and evaluate one for an element that is Every time you call it, you just have two values. You put in the end of the. It has three nodes. And the idea is that it is the two. All you need is value yes. Just that's it. Or but the UH is a lot of numbers. Pero we have the array of one. Why? I mean, you just need to plug it. Yeah, don't save it. Just do PMT dot plot, and then over that X plug that UH inside the for loop. So it will do 5 plots. So just do PMT dot plot and then X comma UH. It will, yeah, it will add to the same. If you do that, then it should well, your element nine, the round parentheses is not correct. It should be every time you access an array string with a square. All right, 10 minutes, I'll do it. Put you out of your struggle. So let's do it. Where do I have? I don't know which one is. Oh, this one. I think it's this one. Let me do it very quickly. So I have 10 minutes. I'll try to do it in 10 minutes. This one, import numpy as MP. And then from matplotlib import pyplot as PLT. The first thing, defining the shape functions and the derivatives. So the shape function is a function of X, so I need to pass X, but every element will have a different shape function defined by the nodal coordinates of that element. So I need to pass somehow the information of the coordinates of that element. I'm gonna pass them in this vector param, and then I'm just gonna access that here. So I'm just gonna say, that vector param has the first and the second coordinate of a given element, and that's all I need. Then I can return my function. So that is a linear shape function. So this is just as it appears in class. The second shape function, it also takes X, and then I also need to know the nodal coordinates, so I also will need to pass the param. And then that shape function looks like this. If I want the derivative, actually, I will just copy this. The derivative of the first shape function is just 1 over that, and the derivative of the second shape function is just 1 over that. That's it. That's the shape functions and the derivatives with respect to x. Hopefully you did do that. Then I need my mesh information and node u values. That I just will do exactly like I said in the node. So this one I said 0, 5, 1, 2, 3, 4. Then elements I said 0 and I forgot now what this was. 0 and 2. Then 2 and 3. Then 3 and I think here I changed. Do you mind checking what did I do? 0, 2, 2, 3, 3, 4. Then I said 5, 1. And then 4, 5. And finally, I said new node u was an array 1, 32, 2, 4, 8, 16. So that's the information that I gave you. So then you know that the interpolation is for each element. For example, UH of x is just the sum of ni times ui, right? So I said that because this UH is defining of each element, I will need a loop over elements because I can only do this sum for each element. So I will need a loop over elements. So for I in range and the number of elements, you know the number of elements, otherwise you can just do len of elements. This will give you the length of that array. So I have a for loop over elements. So for each element, I need to plot. So somehow I need to do UH equals N1 of X param of this element. So let me call it param E times U1E plus the second shape function times U2E. So somehow I need to evaluate that, right? I need to evaluate the first shape function for this element at some x values, the second shape function for this element at some x values, and I need to multiply by the corresponding u value at the beginning of the element and the corresponding u value at the end of the element. This is really the main thing is how do I access this u1 and this u2? I for sure need to get them out of this node u. So I will need to get u1e out of this node u array. And I also need to get the U2 out of this node U array, but where, how, which number do I put here? That's the question. For the X I also need to evaluate a bunch of X, right? So X, I will do the same way that I did it on Wednesday. I need linspace, but again, I need to go from X1E to X2E, and then let's say I want 50 points. But here, there's another thing that I don't know. For this element, where does this element start and where does this element end? Somehow that information is in the node X array, but I don't know where to get it. So where does this element start and where does this element end? For sure, it's in the node X array, but I need to define where do I get it from? And that actually, the same index that I use here is the one that I'm going to use here. The same index that I use here is the one that I use here. And this is really the main thing is to know what node to access. That information is in the elements array. So this is go get the node labels that make up element I. So if I print element I, this print 0, 1, 2, 3, 4. And here is made out of nodes N1 and N2. And these are the ones that I need here. I'll print it in 1 sec. I'll do shift enter for this, and you'll see this will print element, and then instead of I, it will print 0, 1, 2, 3, 4. And it's gonna tell me, it's basically gonna spit out this array, right? So element 0 is made out of nodes 0 and 2. Element 1 is made out of nodes 2 and 3, and so on. So when I hit enter here, it's not liking this because param E is not defined. Param E should have this information, x1 E, x2 E. So it says element 0 is made out of nodes 0 and 2. Element 1 is made out of nodes 2 and 3. Element 2 and so on. And because we are out of time, I'll just plot it, right? So here I'm just gonna plot, we'll add to the plot. I didn't do I'll do the derivative and I'll upload the derivative, but the main thing here is, I'm just gonna print one extra thing. So I'm gonna say node, and then N1 has coordinate x1e, and node N2 has coordinates x2e. So this goes and reads the element array, gets the two nodes that make up the element, then given those labels, goes to the node x, gets the x coordinates, and then goes to the u and gets the corresponding u values. Has u value u1e, and the second one has u value u2e. And that's it. Inside of each element, at the end of the day, this is what we use. Sum of shape function times the nodal value for that element. Questions? I'll upload this and the derivative, but hopefully it kind of makes sense. I'll see you Monday.
Yeah. Like I originally what you but how do we know which situation we want?
Oh, it's always, they should be arranged in the same order as the node label. So the columns and the rows should correspond to the node numbers. So, U1, U2, U3, U4.
Okay. And then
on you. It's completely arbitrary. You can do whatever order you want. Now, for these problems, if you want to do the split of the block matrices, always name the node with boundary conditions first. And then, so if you have only boundary condition on the left, then you can just do 0, 1, 2, 3, 4, etc. If you have left and right boundary conditions, then you should do 0, 1, and then all the middle ones.
Okay, thank you. Yeah, that's okay, so thanks.
Yep. We can go to my office.
Ask just have a quick question about the homework. Do you want, where is your office?